Okay, day 2 video for section 7.3. We're going to be writing the equation of a hyperbola given some information. And the information we're being given is we have a foci of -1, 9 and -1, -7 and a conjugate axis that is 14 units long. Okay? Well, what is this telling us? Well, the conjugate axis is where we get B from, right? And so if the whole axis is 14 units, each B coming away from the center is half of that. So we know that, in this case, the B is going to be 7 because it's half of that conjugate axis. The foci being at -1, 9, and -1, -7, if we look at a really quick sketch here, -1 and 9 is like this, and -1, -7 is like this. And so our foci are, remember, outside of our graph, but that means that our graph is going to be going something like this, which means that Y is the major axis. And so now that we know that, we can start with a base equation. Well, our base equation is going to be y minus k quantity squared over a squared minus x minus h quantity squared over b squared equals 1. So we need h and k, a and b. Okay. So we need to find our center. So our center, if this was 9 units up and a -7 units down, then if I go up 7, I'm at 2. That means the center point is going to be here at -1, 1 is going to be my center, because it's the midpoint between -1, 9 and -1, 7. What's the midpoint between 9 and -7? It's a +1. So that means that I'm going to have y minus a +1 squared, and I'm going to have x minus a -1, which means x plus 1 quantity squared. The two terms are going to be subtracted to get our 1, and I just need a and b. Well, b was 7, so b squared is 49. I need a squared. How do I find a squared? Well, I remember the fact that c was equal to the square root of a squared plus b squared. Remember, it's added because we're talking about hyperbolas. In ellipses, it was subtracted, but this is hyperbola. So I've got b squared, I need a squared. Well, what's a squared? Well, if we remember, a squared is the distance of the major axis, which I don't have. Instead, I have the foci. Well, the foci was the difference between those foci. 9 and 7 is 16 units. Half of that is 8. That 8 represents C. So I have C, I have B, I need to find A. I square both sides. C squared equals A squared plus B squared. Well, that means 64 is going to equal a squared plus 49. I subtract the 49 over, and I'm getting 15 equals a squared. I don't need to take the square root and find that because I don't need a, I really just need a squared, 15. And that's how we go through with sketching and thinking about what parts we have to come up with the equation of hyperbola given pieces and parts. Okay, to identify different conic sections. I'm actually going to use a new page for this. Identify the conic section. (18x minus 3x squared plus 4 equals a negative 8y squared plus 32y. I'm going to look at 4 of these. 12y minus 76 minus x squared equals 16x. Number 3, 5y squared minus 6x plus 3x squared minus 50y equals a negative 3x squared minus 113. And number 4, x squared minus 4x equals a negative y squared plus 12y minus 31. Okay, how do we identify these without taking all that time to figure it out and get them into standard form and be like, oh, well, it's that. Well, there's some tricks we can use for the trade. The first one is we need to put the squared terms on the same side. Okay, so for this first one, if I add 8y squared over to the left, I'm going to get a negative x squared term and a positive y squared term. Well, remember, anytime we had opposite signs, helps if I spell signs right. It's been a long day of recording. You've seen this shirt a few times. Okay, I don't come in numerous days with the same shirt. Opposite signs on x squared and y squared, remember, that's what we've been currently studying. Those are hyperbolas. Okay? The second one, there's not another squared term to move over. There's only one squared term. Well, remember, when we had only one squared term, those were the first ones we studied. Those were the parabolas. And if it was an x squared, it opened up and down. And if it was a y squared, it opened left and right. For the third one, we have y squared, x squared, and another x squared. So I got to move this over. That's going to give me 6x squared. So I'm going to have a 6x squared and a 5y squared. They're the same sign. So we have the same sign on x squared and y squared. Those are the ellipses. And here again, we move this y squared over. I get y squared and a positive x squared. They're the same sign. And the same coefficient this time. When that happens, it's going to be like an ellipse, but it's the special case, which means it's the circle. Okay? That's the quick and easy way of determining which conic section you have based on pieces and parts without going through and solving it into standard form. And that's the end of section 7.3. I will see you for 7.5.